So this question gives us the equation 5 times 5 to the power of log x plus 5 to the power of 2 minus log x equals 30, x being greater than 0. And we need to find x. I'm going to write the equation under it over here. So 5 times 5 log x plus, so I want to get rid of the 2 minus log x. So that means we'll have 5 squared over 5 to the power of log x equals 30. So of course you can write the 5 squared as 25 over 5 to the power of log x equals 30. Now let's multiply both sides by 5 to the power of log x. So we get rid of this over here. So we'll get 5 times 5 to the power of 2 log x, because of course one lot of log x plus another lot of log x will get 2 lots of log x, plus 25 equals 30 lots of 5 to the power of log x. Now we can actually divide through by 5, which will make this a lot easier to work with. So if we divide both sides by 5, we'll just get 5 to the power of 2 log x plus 5 equals 6 lots of 5 log x. Now let's get all of the variables on one side. So we get 5 to the power of 2 log x minus 6 lots of 5 to the power of log x plus 5 equals 0. So I think it's at this point that lots of people will get confused, as in they would not know how to react to something being to the power of a log. And actually the trick here is to notice that we're actually dealing with a hidden quadratic. So if we say 5 log x equals y, for example, and we substitute y into this equation, we'll actually get a nice, easy to work with quadratic. So 5 to the power of 2 log x, when we substitute y into that, we'll get y squared, because we have 2 lots of that, minus 6 lots of y, plus 5 equals 0. This factorizes nicely into y minus 1 multiplied by y minus 5 equals 0, and then our values for y is y equals 1 or y equals 5. So now we can substitute these values into this equation and we can find the values of x. So that will be 5 to the power of log x equals 1. So we'll do log 5 of the 1, so we'll get a log x equals log base 5, 1. And whenever we just got log x on its own, we can assume it to be, well, it's going to be log base 10x. So you should just remember that when you're doing exam questions and they don't show the base, it will always be base 10. And that equals 0, therefore x equals 1. Because log anything 1 is always going to be 0. So log base 10 will be 0 as well. So one of our x values is going to be 1, and our corresponding y value will be 1 as well. And our next one will be 5 to the power of log x equals 5, because we substitute y equals 5 into it. You can easily work out from that log x equals 1, because that's just 5 to the power of 1, and that's log x. Therefore x equals 10, because of course this just means log base 10 of x equals 1. Therefore x is 10, as log base 10 of 10 is 1. So x equals 10, and the corresponding y value, which we don't need in the answer, is y equals 5. But our two answers to this question, x is greater than 0, is, the answers are x equals 1 and x equals 10. I hope you found this video useful. The main trick in here was to realize that we're working with a hidden quadratic. I've zoomed out here so you can have a better look at the working out. Take a picture if you want to, and if you have any questions, feel free to let me know in the comments down below.